Today we are going to be talking about solving trig equations. By the end of this video, you should be able to solve trigonometric equations for all values. First, let's start with a little bit of a review on factoring. So, if we have 3x squared plus x minus 2 equals 0, and we need to factor, there are several methods that you can use to factor. You can use trial and error, you can use factor by grouping, you can use the box method, you can use whatever method you want. I'm going to show you factor by grouping. If you want to look up other methods on the internet, that's totally fine. So for factor by grouping, you need to take A and C and multiply them together. Then you need to find two numbers that multiply to -6 and add up to 1, which is B. So that'll be +3 and -2. So then I'm going to split up the middle term . So I am uncombining like terms. I'm taking the 1x and splitting it into 3x minus 2x. So then I am going to group these terms, and I'm going to factor the GCF out of each of these. So the GCF of the first set of parentheses is 3x, and I'm left with x plus 1. The GCF of the second parenthesis is -2, and I'm left with x plus 1. These should match, otherwise you made a mistake. Now we have to factor the GCF out of this term and this term, which our GCF is going to be x plus 1. If we take that out, we are left with 3x minus 2. Then we just solve this. X plus 1 equals 0 gives you x equals -1. 3x minus 2 equals 0 gives you x equals 2/3. Let's take a look at one more example. If we have x squared equals 4x, the first thing we need to do is make this equal to 0. So I'm going to subtract 4x from both sides. Then I'm going to factor out a GCF. So I can factor out an x. I'm left with x minus 4. So I want to do x equals 0. X minus 4 equals 0 gives me x equals 4. So those are my answers. You do need to remember all of your algebra rules when we go to solve trig equations. So our first trig equation is 2 sine of x minus 1 equals 0. So first I am going to isolate sine of x. So I'm going to go ahead and add 1 and then divide by 2. So I get sine of x equals 1/2. Then I need to think about the unit circle. Where is sine equal to 1/2? Remember, sine is the y value. So that will be at those two angles, which are pi over 6 and 5 pi over 6. Now, solving trig equations is different than inverse trig functions. With inverse trig functions, we were only looking at half of the unit circle with each of those inverse trig functions, but it is not the same thing with trig equations. You are looking for any value on the unit circle where sine of x equals 1/2. Now, these are not the only two answers. We could keep going around the unit circle, and every revolution of the unit circle will give us another value. So I'm going to put plus 2 pi k on each of these. and k is some integer. So you are adding multiples of 2 pi or subtracting multiples of 2 pi. But these are our answers. Let's take a look at the next one. I have cosine of 2x plus square root of 2 equals negative cosine of 2x. So I'm going to add cosine of 2x to both sides. And then I need to isolate cosine of 2x. So I'm going to subtract square root of 2 and then divide by 2. Again, I need to think about my unit circle. Remember that cosine is the x value, so cosine is equal to negative square root of 2 over 2 at 3 pi over 4 and 5 pi over 4. Since we have cosine of 2x instead of cosine of x, I'm going to write out that 2x is equal to 3 pi over 4 plus 2 pi k, and 2x equals 5 pi over 4 plus 2 pi k. Then we divide these by 2 to get x by itself. So I end up with x equals 3 pi over 8 plus pi k and 5 pi over 8 plus pi k. And those are our answers. Next, we have 3 tangent squared of x minus 1 equals 0. So I'm going to isolate tangent squared of x. So tangent squared of x equals 1/3. Then I need to take the square root of both sides. Remember, when you take the square root, you have plus or minus. And then we need to rationalize the denominator. So I have tangent of x equals plus or minus square root of 3 over 3. So then we need to think about our unit circle. Where is tangent either positive or negative square root of 3 over 3? Well, that occurs at 4 places. So you could write out 4 different answers. X equals pi over 6 plus 2 pi k, x equals 5 pi over 6 plus 2 pi k, 7 pi over 6 plus 2 pi k, and 11 pi over 6 plus 2 pi k. But there's a more efficient way to write this. You'll notice that these two are opposite each other on the unit circle. So we can be a little bit more efficient and say that x equals pi over 6 plus pi k, because you go halfway around this unit circle and you get 7 pi over 6. Similarly, 5 pi over 6 and 11 pi over 6 are halfway around the unit circle from each other. So we can more efficiently say that x is 5 pi over 6 plus pi k. If this shortcut confuses you, that's fine. You can write out all 4 answers. It's just not as efficient a way to write the solutions. Let's look at the next one. We have cotangent of x times cosine squared of x equals 2 cotangent of x. We have 2 different trig functions here, but we'll get to that in a minute. Let's start by setting it equal to 0. So I'm going to subtract 2 cotangent of x from both sides. Then I'm going to factor out a GCF. And my GCF is going to be cotangent of x. Well, since we just factored, we can set each of these factors equal to 0. So I have cotangent of x equals 0, and cosine squared of x minus 2 equals 0. So let's just focus on cotangent of x equals 0 first. We know that cotangent of x is cosine of x over sine of x. And for a fraction to equal 0, the numerator has to equal 0. So really, we're just looking at when is cosine equal to 0. So if we look at our unit circle, cosine is the x value. So cosine is 0 at pi over 2 and 3 pi over 2. So we can write that as pi over 2 plus pi k. Now let's look at our other factor. We had cosine squared of x minus 2 equals 0. So if we add 2 to both sides and then take the square root, we get cosine of x equals plus or minus square root of 2. Well, square root of 2 is bigger than 1, so that never happens on the unit circle. So our only answer is x equals pi over 2 plus pi k. Next, we have 2 sine squared of x minus sine of x minus 1 equals 0. We're going to factor this just like we factored algebra quadratics. This is the same as if we had 2x squared minus x minus 1 equals 0. So if it helps you to write this without the trig functions and then factor it and then switch back, that's totally fine. So if we factor this, we would end up with 2x plus 1 times x minus 1 equals 0. If you go ahead and solve these, you end up with x equals negative 1/2 and x equals 1. So we can use this, and we have sine of x equals negative 1/2 and sine of x equals 1. So we just need to think about the unit circle. Sine of x equals negative 1/2 at these 2 points. Sine of x equals 1 at 1 point. So we have x equals 7 pi over 6, which is this angle, plus 2 pi k, and x equals 11 pi over 6 plus 2 pi k, and x equals pi over 2 plus 2 pi k. And those are our answers. Next, I have 2 sine squared of x plus 3 cosine of x minus 3 equals 0. So this almost looks like a normal quadratic, except we have 2 different trig functions. So we're going to use our Pythagorean identities to change this to be just in terms of cosine. I know that sine squared of x is the same as 1 minus cosine squared of x. Then I need to distribute. and combine like terms. Having a negative leading coefficient can make factoring a little challenging, so I'm going to divide everything by -1. Now I can factor and solve. If you need to change this to just be 2x squared minus 3x plus 1 so that you can factor, that's fine. If you need to factor the long way, that's fine, but I'm going to skip those steps. Now we just solve. So I get cosine of x equals 1/2, and cosine of x equals 1. So if I look at the unit circle, cosine of x is equal to 1/2 at these 2 points, and cosine of x is equal to 1 at 1 point. So my answers are x equals pi over 3 plus 2 pi k, and x equals 5 pi over 3 plus 2 pi k, and x equals, you could write 0 plus 2 pi k, but that's just the same as 2 pi k. So those are our solutions. Lastly, we have cosecant of x equals -2. Well, we know that cosecant of x is the same as 1 over sine of x. Now, I can take the reciprocal of both sides and have sine of x equals -1/2. Then I just look at the unit circle. Sine of x equals -1/2 at these two angles. So I just have x equals 7 pi over 6 plus 2 pi k, and 11 pi over 6 plus 2 pi k. And those are our solutions. So, as you solve trig equations, you will have to use some algebraic techniques, including factoring, and you will probably need to remember some of your identities.